Good morning, everyone.
Morning.
Morning. Good morning.
Hello. All right, we got just a minute. Any quick questions while we're waiting for everyone to get in before 11 o'clock hits? All right. Gotta get my iPad. There's the link one more time. And I now see that it is 11 o'clock. So, just to be super duper safe, there's the link again, and your quiz is now active. You're given the function f of x is secant of x. What is the derivative of secant of x? What is the derivative of secant of x? Share it for the recording. So, daily quiz for today. Again, function secant of x, what is its derivative? You have your choices. Select the right one. I'm going to give us just till 11:02 because again, this is, 11:02. This is just something that you should know. If you need to quickly derive it, you can. I know we've already got about half of people responding, so that's good. Here's the link one more time, just in case some people came in at the last minute and I didn't see you. While you finish that up, I'm going to go get my tea. All right. 241. All right, I'm going to give you all, let's see, it's at 11:02, just turned 11:02 for me, but I'll give you 10 more seconds. I think we got everyone in. Give me at least your best guess. 5, 3, 2, 1. I'm locking answers now. I just saw a chat. Let's see if you got in. Hold on, someone's having some technical difficulties. Let's see if they're going to respond, because I don't want to ruin it, because they're here, they're trying to take the quiz. I want to give them the chance to, but you messaged me, you need to check your Zoom. All right, hold on just 1 second, y'all. Share screen. For the person who's messaging me in chat, tell me which one is your answer. First, second, third, fourth, fifth, or sixth option. First, second, third, fourth, fifth, or sixth option. I'll give you 15 seconds to type it in. And just send it to me as a private chat like you've been doing. first, second, third, fourth, fifth, or sixth option. Cool, got the answer. Stop sharing. All right, so you're asked for the derivative of secant, and most people did get it right. I'll show that it is the first option, or second option, secant tangent. That is the correct answer. Secant tangent is the correct answer. If you went through, and I can do it really, really quickly, even if you would have forgotten, you can use quotient rule to have solved this, because if I'm trying to find the derivative of secant of x, whoops, let's see there, this is the same thing as the derivative of 1 over cosine of x. And if I use my quotient rule, low d high minus high d low all over low squared, means this would be my low, which is cosine of x, times the derivative of 1 minus 1, my high, times the derivative of, whoops, wrong thing, of cosine all over x divided by cosine squared of x. Derivative of any constant is 0. So this will be a 0, which means this entire first term will get canceled out. I take the derivative of cosine, its negative sign, and how that, since I'm subtracting a negative, becomes a positive. So I'll have a sine of x over cosine squared of x. And I can rewrite this as a sine, or let me do 1 over cosine of x times sine of x over cosine of x, which is my secant of x, tangent of x. Okay, so even if you don't remember it, you can always derive it. And you're always able to derive it, but which one is probably a little bit easier? Remembering it or always deriving it? I guess you get to choose.
Memory.
Yeah, but memorize is definitely the easier path, right? And that's the same with all of those trig functions. You can derive what they are every single time if you do forget, but it is much easier if we memorize. All right, any quick, or not quick questions, any questions? Any questions? All right, thank you, Deanna, for giving me that thumbs up. Yeah, same rules always. Sometimes I forget to say it, but if you're good, give me a thumbs up. If not, ask questions. That way we're not just sitting here, I'm staring at a lot of black screens. Cool, cool, cool. Thank you all. All right, so today we are going to be working with chain rule. Chain rule is traditionally one of the trickier topics for students, but once you see it, you get it. Okay? But it does depend upon a skill of being able to see what you're given as a composition of functions, as I see one function inside of another function. So the first thing I'm going to do is ask y'all to do that. So we're given the following function. I'm going to share screen so we get it in the recording. This function h of x, okay? It is x squared plus 4x plus 1, all of that to the 7th power. And what I want you to do is just look at this function and see, can I see this as a composition of two functions, f and g? In case you forgot function composition, that means I have a function inside of another function. So g of x would be my inner function, f of x would be my outer function. And there's a hint in that the way you read it, and the way I just read it, x squared plus 4x plus 1 to the 7th, gives me my way of seeing this as a composition of the two functions. So I'll give you all a second. I'm going to stop share. Just select your answer. I'm going to give you all no more than just a minute.
For two of the answers, isn't it supposed to be 1 instead of 7?
Yes. Let me fix that. But yeah, looks like most people got it. That was a copy paste error. Thank you. You should now see it changed on your screens. Thank you for pointing that out. Missed this argument today. All right, I'm going to give you all just 10 more seconds to finalize submitting answers, but it looks like most everyone selected one. 5, 3, 2, 1. Locking answers now. Oops, I got a couple people. All right, now I'm going to lock. Cool. Again, 73% of y'all got the correct answer, but at least no one guessed one of the answer choices that had cosine. Because hopefully you did notice there is no cosine in here, so I'm looking at the compositions. Cosine shouldn't be included, but it would be this one. So when I look at my two functions right here, g of x is what I'm plugging inside of my f of x, whatever I choose to be my f of x. So g of x is the inner function, what is inside. F of x is the outer function, the stuff after that. So if I look at this composition inside of this seventh, I have that x squared plus 4x plus 1. So that polynomial, that quadratic x squared plus 4x plus 1, that would be my inner function. Okay? Then outside of that, my outer function would be raising it to the 7th power. And that's what f of x is describing, taking whatever you give me and raising it to the 7th power. And what we're doing here is we're going to be giving it x squared plus 4x plus 1. So that's how we get this total, x squared plus 4x plus 1 to the 7th. That is x squared plus 4x plus 1 is inner, the 7th is outer. Okay? So now that we have that, and you should have watched the videos for chain rule, okay, but I'll give you the very, very quick definition. So if I'm looking at the derivative of the composition of two functions, so I can see this as one function g of x inside of another function, f. To find the derivative of this composition, it is always just take the derivative of the outer function. I plug back in whatever my inner function was. My inner function doesn't change inside the derivative of f, but both f and g differ with respect to x. They're both going to be changing differently with x. So I need to also incorporate in some manner how g of x changes, how g of x is affecting the slopes of all of these tangent lines for this composition. So what we do is we take the derivative of the outer, plug back in the inner function into that derivative. And that's why we get the f prime of g of x. And then we multiply by the derivative of the inner function. This is chain rule. This is what you should have been watching in those videos because they go through it. So, next problem. So for that function, find the derivative of it. And you have to use chain rule. You have to use chain rule. Okay. I'm leaving the chain rule up there for you on Zoom too. So if you need to come back to it and look at it, you're more than welcome to. Alrighty, so I'm going to give you all just one more minute. Just one more minute though. So we've got about half people answering so far, which is good. Sorry, I'm trying to type up one more example. All right, we're just waiting for a couple more. I'm going to give you all just 15-ish more seconds. 15-ish more seconds. All right, 5, 3, 2, 1. Oh, my internet went slow. Hold on. Not to lock answers. So for the, what is it? We're missing 3 responses. So for you 3, okay, why is this? Okay, I didn't lose internet connection. Give me a thumbs up if you're still here, because my web page is not loading now. That was weird. Okay. Give me a thumbs up if you're here with me, because I just got kicked out. It's my Wi-Fi switched over. So give me a thumbs up if you're still here. Cool, cool, cool. Recording's still going. That's good. All right. So now that I am situated, let's get in. Hey, we had more people answer. So I'm going to lock answers now. Okay. Looks like most of y'all got it correct. So let's leave that, and 71% to be specific. So we're trying to find the derivative of the function x squared plus 4x plus 1 to the 7th power. And we said when I look at this, I can see it as the composition of 2 functions. I have an inner function and I have an outer function. So that inner part, what would be for my chain rule, the g of x, is that x squared plus 4x plus 1. Right? That's what's inside that raised to the 7th power. And then my outer function, f of x, was that x to the 7th. So if I'm wanting to follow a chain rule, I want to, again, find, as we've seen with product rule and quotient rule, find the derivative of these 2 independently, then just make sure I plug them back in correctly. So I need to find the derivative of the inner function. Well, this is a nice little quadratic. Hopefully we're feeling a lot more comfortable with it now, because I just take the derivative of each individual part of that quadratic, which will leave me with a 2x plus a 4, because the derivative of x squared is 2x. The derivative of 4x is just 4, and then the derivative of 1 is a 0. All right, so we don't write that plus 0. Leave it. And then the derivative of my outer function, my x to the 7th. Well, that's just nice, good old power rule. So bring that exponent down, rewrite my variable, and subtract 1 from it. Now, this is, again, where the key is to look at the chain rule. Again, we say the derivative of this composition is take the derivative of my outer function, and then I plug in my inner function. So I need to figure out, what does f prime of g of x look like? Well, if I just give it the function g of x, that x squared plus 4x plus 1, my derivative says I'm going to take whatever you give me, raise it to the 6th power, and then multiply it by 7. I'm giving it the function g of x. That means it's going to take that g of x, the x squared plus 4x plus 1, raise it to the 6th power, and multiply it by 7. Okay. And then I would need to make sure when I find the overall derivative, I multiply it by my g prime of x. So then this derivative total will end up being 7 times x squared plus 4x plus 1 to the 6th power. And then I need to multiply by the derivative of the stuff inside that g prime of x, which we said is 2x plus 4. And just to write it down here below, this is that f prime evaluated at g of x times the derivative of the inside times g prime of x. So that is why the last answer would have been the correct one. You can see it as we essentially apply the power rule to that outer function, right? Apply the power rule, bring the exponent down in front, subtract 1 from it. But then I want to make sure I'm also keeping account for how the stuff inside is changing. And that's where this multiplication for the derivative. There is a natural reason why it's there, but because I want to make sure I'm going through examples, I'm not going to go through that. I know your textbook does go through the derivation of the chain rule. Okay. But same question for this example. Right? Same question as always. Give me a thumbs up if you're feeling good. You understand it. If not, ask a question. And thank you all for a lot of people with videos on today.
I have a question.
Go for it, Bevy.
When you did the g of x part, how come you didn't, when you did the derivative, how come you still have the 1? Isn't a 1 supposed to be like a 0?
The derivative of 1 is 0. Yeah. And that's what happened from, let me do green to show the relation between the two, right?
Yeah,
My
so
function is that x squared plus 4x plus 1. And then when I take the derivative of it, it becomes a 2x plus 4. Yeah, so what you're saying though,
so when you're putting it back in the formula, that's why you're just putting back the 1 in there, because that's a part of the whole equation, correct?
because I'm not plugging in right here, right? When I'm what I'm plugging into my derivative of my outer function, I'm not plugging in the derivative of the inner. I'm just plugging back in whatever was the original. That's that G of
Okay. All right.
Because you got someone doing yard work near you. Oh, you got it. Never mind. All good. All good. All right. So, any other questions? Any other questions? All right. Let me finish editing this. I want to give you multiple choice answers. Hopefully, since I did this one the last minute, there is not a mistake. Let's do one more. So go back to poll everywhere for me, please. Similar type of problem. Similar type of problem. Again, where we're going to have to use chain rule. All right, already getting some good answers in. Quickly too. Oh, let me share it for the recording. Always remember to do that. This time we're trying to find the derivative of 2x cubed plus 4x squared, all of that raised to the -3rd power. The derivative of 2x cubed plus 4x squared, all of that raised to the -3rd power. let me give you all, let's see. All right, I'm going to give you just one more minute. And so we're making sure that we're moving along. I've got more examples for us to do. So make sure you give me your best response, and hopefully we can get up to 28 again. Even though there's 29 of us in here, we can at least get to 28. And just a reminder, I am looking at who's responding and who's participating. And that does get factored into your overall grade. So make sure that you are participating. All right, 20 seconds. Just give you a heads up. All right, I'm gonna lock answers here in 5, 3, 2, 1. Locking answers now. I saw a bunch of people changing, so now I'm gonna lock. Cool, again, 71% got it correct. Good job, everyone. So let's just go through it real quick again for the rest of you, just to help clear some things up. This one, you know, because the answer choice is a little bit about making sure you read the right answer. If you made a small mistake, you made a small mistake. Okay? But again, this is chain rule. I can see from this composition, I have a function inside of another function. So what is my outer function? It is a power function, right? But what is it? I want someone to please unmute themselves and tell me.
Isn't it x to negative 3?
Yeah.
Negative third number.
X to the negative 3. Absolutely. Right? And my inner function, which is that stuff inside of it, that 2x cubed plus 4x squared. And I can, again, even get that queued up from when I just read the function. Because when I'd read this, I would, the over thing over here, right? I'd read this as 2x cubed plus 4x squared. It's my inner function, what I'm reading first, to the third power. Right? I can even see it when I'm reading it to myself. I'm already separating these things into two separate functions. I just have to also make sure that I'm recognizing that. And that's going to make it easier for me to find my inner and outer. But again, I need to find the derivative of both of those, both my inner function and my outer function. Derivative of my outer function, again, is a nice good old power rule. So negative 3x to the negative 4. Bring that exponent down, multiply by it, and subtract 1 from it. Negative 3 minus 1 is a negative 4. If I do the derivative of that inner part, well, the derivative of 2x cubed will be a 6x squared. Again, power rule, bring the exponent down, multiply by it, and then subtract 1 from the exponent. And then it'll be plus an 8x. So let me rewrite that 8. So now I have all of my parts. I just got to follow what the chain rule tells me to do. I take the derivative of the outer function, that f, and plug in my inner function, g. So that means this derivative is equal to my outer function with my inner function intact. So negative 3 times 2x cubed plus 4x squared to the negative 4th power. But I'm not done, because the chain rule says I also need to make sure that I multiply by the derivative of the inner function. So then I'm going to multiply by the derivative of 2x cubed plus 4x squared, and that will be my 6x squared plus 8x. And once you get to the point, just the heads up, once you get to the point of being able to recognize what is your inner and what is your outer function, you're essentially doing all that stuff in that top right corner where we explicitly wrote out that f and g and then f prime and g prime. And you can go straight from the derivative of the function itself to its derivative just by looking at it. That is something that as you get more and more practice with this, you're going to see that it's easier to pick up on. For example, we just do it in green to separate it as a new problem. If I was trying to find the derivative of, no, let's do sine of x to the 5th power. Right? Again, I see having two functions. My inner function would be sine of x. My outer function would be raising it to the 5th power. So x to the 5th, which means my outer function, I take the derivative of first. Since it's a power function, I apply the power rule. So I bring the exponent down, leave what's inside, subtract 1 from my exponent, and then I multiply by the derivative of the inside. And what is the derivative of sine? Someone unmute themselves. Derivative of sine is?
Sine?
Not sine,
Cosine X.
cosine.
No.
So Shanice, it is just cosine. Just cosine. Because I saw you put it in chat. Thank you for participating in chat as well. Right? Because the derivative of cosine, or derivative of sine is cosine, the derivative of, let's just write it out real quick, what we learned last Wednesday. If I can fit it in here. Derivative of sine is just cosine, but then the derivative of cosine is negative sine. So that's what we learned on Wednesday. But as you can see, chain rule, applying the chain rule again, it's just being able to recognize what's your outer function, your inner function, do the derivative of the outer function, leave the inside alone, and then multiply by the derivative of what is inside. So, same as always, thumbs up if you're feeling good, ask a question if not. And please, please, please ask a question.
I have a question.
Go for it.
Oh, actually, I wrote that wrong. Never mind. I was gonna ask how you got the -4 in the top one, but I wrote it wrong. Sorry.
Gotcha.
never
No,
mind.
all good, all good. Any other questions? Cool. See a thumbs up. All right. So, I'm going to deactivate that. However, what our outer function is doesn't always need to be a power function. It's usually the way we like to start off, because it's a little bit easier to see. But our outer functions can be other things. We can have many functions inside of functions. So here is the next problem. If you go back to poll everywhere, I want you to find, excuse me, the derivative of cotangent of x squared. I want you to find the derivative of cotangent of x squared. And this time, not giving you a multiple choice. This time I want you to type it in partly so you can get some practice, because for all of your web work, you're going to have to type in your answers. So I'll give y'all, let's see, it's 11:33. I'm going to say till 11:36, so 2.5 minutes to do this and type it up and hit enter. All right, make sure you're working on this problem. Derivative of cotangent of x squared. Interesting, but good. Seeing some good answers come through. All right, we got most of y'all in. Whoops, I'm not giving y'all enough warning. I'll give you 30 seconds just to kind of quickly type up if you haven't started that yet, or finish typing up and hit enter. It's gonna be a little bit after 11:36, but that's fine. Already got most people in anyway, which is good. Happy y'all? Very happy. All right, 10 seconds. 5, 3, 2, 1. I am locking answers now. Go ahead and hit enter real quick if you have something typed in, even if it's incomplete. Locking answers now. All right, so a good majority of y'all ended up getting the correct answer. So good job, right? But it's all about, again, recognizing what is your inner function and your outer function. And when we're doing this stuff, if we want to do some scratch work, we're usually going to reserve f of x to be outer and g of x to be inner. So I want someone to unmute themselves and please tell me what is the inner function?
X squared.
Yeah, x squared. I can even see it because it is inside of a certain function, and what function is it inside of? I.e., what is my outer function?
Cotangent.
Yeah, outer function is cotangent. So what I'm doing is I'm taking that x squared, and that's one function, my inner function, and I'm plugging that into another function, the cotangent function, which is my outer function. So again, I can go through this process of saying individually, what are the derivatives of both my outer and inner? And this means I need to remember what the derivative of cotangent is. Yes, you can always derive it using quotient rule if you do forget, but this is hopefully something that you will memorize very quickly. Well, not very quickly, you need to memorize before too long, I guess is what I'm trying to say. So someone please unmute themselves again. Tell me, what is the derivative of cotangent?
Negative.
Oh, go ahead.
Go ahead.
Y'all are fighting over answering. I love it. Go ahead. Someone just answer, though, for me. One person.
Negative cosecant squared x.
Perfect. Negative cosecant squared x. Yeah, who would have ever thought that some people would be fighting over who gets to answer a math question, right? That's awesome. All right, so derivative of the outer function is negative cosecant squared of x, and the derivative of the inner function, I trust that we all have, because the derivative of x squared is 2x. Again, just using that power rule, bringing the exponent down, and then subtracting 1 from the exponent. And then I would want to plug it back in, because remember when we look at the derivative of chain rule, it says derivative of the outer, plug back in the inner function, but then I multiply by the derivative of the inner function. So overall, the derivative of cotangent of x squared is saying take the derivative of my outer function, which is cotangent, or which the outer function is cotangent, the derivative of cotangent is that negative cosecant, why did it switch to green? Negative cosecant squared, and into the negative cosecant squared, I plug in what was originally inside, my x squared function. And then I need to make sure that I multiply by the derivative of what was inside, which is a 2x. And I can rewrite this, and as a couple of y'all did, just so we can make sure that we're reading this correctly, there's no small misunderstanding. It'll be negative 2x cosecant squared of x squared. And all we're doing from here to here is just a rewrite. Just reorganizing our answer. If you would have stopped right here, that'd have been perfectly fine by me. Okay, questions? If not, again, thumbs up.
Okay, wait, I have a question.
Yep, go ahead.
So you said that we would have stopped at the first one. Now, see, I understand the first part, but when you get down to the second part, how did you switch the -2? I mean, how did you switch the secant, the cosecant, the negative sign? How did you put it in front of the 2? I'm not seeing that right now.
Well, it's because multiplication is commutative, right? It doesn't matter what order we multiply things in.
Okay.
So I have a -1 times the cosecant squared of x squared. And then I'm also multiplying by a 2x. So instead of leaving that multiplication by the 2x out the very end, I'm just moving it up front and saying this is now a -1 times a 2x times the cosecant squared of x squared.
Okay.
Thank you for
Okay.
asking.
Yeah.
Questions? All right. So next problem. So this time it's going to look different. Let's do this one. So I'm going to throw y'all into breakout rooms to work on this, because as you saw in this previous homework, and as you're going to see in this week's homework, you can combine all of these rules together, right? You're going to have to use quotient rule, product rule, and chain rule all in one. So you're going to work together, get an answer, and you're going to have to type it in. So I'm going to send y'all to rooms. You should have your requests now. Please join, unmute, turn on your video if you feel comfortable with that. At minimum, unmute, please. Talk to each other, work with each other. Go ahead and accept that breakout room invitation. Make sure you accept that breakout room invitation, please. Ladies, please make sure you accept that breakout room invitation. Thank you. All right, so let's write it up, and then we're going to go join some people if you're watching the recording. Which I know a couple of y'all in here actually do. So, cool, do that. I'm trying to do the derivative with respect to x of the function. 3x plus 1 squared all over cosine of 3x. Let's give you a warning because it is a lot to type in. Let's see. All right, so who do we want to join? Let's see, always join one of the lower ones. Let's join breakout room 2. Actually, no, I said I'd join the lower ones. Let's do breakout room 6. Okay, I can't join a breakout room apparently. That is weird. Well, I'll just give them a minute. So while you're watching the recording, the key here is, again, you apply the quotient rule. So this means that it is low d high minus high d low all over low squared. So I know I can go ahead and shortcut at least one part of it because I know I need to square the denominator. So that's the easy part. Then I have to look at, okay, low d high. So this means I take my lower function, bottom function, cosine of 3x, but then I need to multiply by the derivative of 3x plus 1 squared. I'm going to subtract from high, so my 3x plus 1 squared times the derivative of my lower function, which is cosine of 3x. So I'm gonna have that set up for y'all. Essentially, this is just applying the quotient rule, and then we see in that quotient rule, when I look at the derivative of the top and bottom respectively, I need to apply chain rule there. So that's where chain rule comes in. All right, so let's start bringing people back. Six, yeah. Was all It is a lot to type in while we're waiting for everyone to get back. See if you can type in your answer. It is a lot to type in, as we will see. All right, yep, just like I was telling some people, we're just waiting for everyone to come back. Going through it, and I at least got the first step already set up for us. First step is already set up for us. But I think we have everyone back now. And like I said, it is a lot to type in. So if you're still working on that, don't worry about it. Just stop, come back to or Zoom. We're going to go quickly through the problem. Let's see at least if you got to the same part that I am going to get to. So when I'm looking at this, the first thing I notice is I'm dividing two things, so I should apply the quotient rule. Low D high minus high D low all over low squared. So I get what we see right there on the right. Cosine of 3x times the derivative of 3x plus 1 quantity squared minus 3x plus 1 quantity squared times the derivative of cosine of 3x. And then the nice little denominator all divided by the cosine of 3x. So now what I just need to figure out is what are the derivatives of that numerator and denominator? The derivative of 3x plus 1 quantity squared and the derivative of cosine of 3x. Well, hopefully, especially after going through the examples today, the derivative of 3x plus 1 quantity squared is a little bit easier to see. I apply power rule to the outer function, which is bring the exponent down, multiply by it, leave what's inside, i.e. plugging back in that 3x plus 1, my inner function, and it would be raised to the 1 power because 2 minus 1 is 1. But we don't ever write that, so it would just be 2 times 3x plus 1, and then I would need to multiply by the derivative of the stuff inside, the derivative of 3x plus 1, which is just 3. And we could then say, oh, I can rewrite this as 6 times 3x plus 1. You can leave it as that. You can distribute that 6 through if you want to. You're more than welcome to. Then I look at the second one, derivative of cosine of 3x. Well, this is where, again, I take the derivative of the outer function. So the derivative of cosine is negative sine. I plug back in my inner function, which was 3x, but then I need to multiply by the derivative of 3x, which is just 3. So this will be negative 3 times sine of 3x. Again, just rewriting. All we're doing is rewriting there. So now I plug that in, and this gives me cosine of 3x times 6 times 3x plus 1 minus 3x plus 1 quantity squared times -3 sine of 3x. Sorry, I know I'm kind of getting off to the side right there. All over cosine squared of 3x. And then just, I'm having to erase some of this so I can finish writing my solution. If I just reorganize this stuff, part of it is it's easier to read. Also because it might simplify some things, which means I have less to type into my homework on web work, or at least in an easier way for me to type it in. Then I'll just have a 6 times a 3x plus 1 times a cosine of 3x. So just rewriting that first term a little bit. And then I'm going to be adding because I'm subtracting what is a negative number because I'm picking up that negative from the derivative of cosine. So this will end up being a plus 3, bringing out that coefficient, times a 3x plus 1 quantity squared times a sine of 3x. Again, just rewriting some of that stuff in the numerator, cleaning it up, and it's all over cosine squared of 3x. From there, you could play with it a little bit more, rewrite it some, see if some things simplified. I don't really see any great way. Great is subjective though, to rewrite it from here. So I would just advocate leaving it here as is. Okay. This is what the derivative is. This would be a lot to type in to WebWorks, and looks like most of y'all kind of got it with your with what I'm seeing. But mainly what I care about is on your own piece of paper, if you got to either of these 2 points, because that is the key of the calculus, applying your quotient rule correctly and applying your chain rule correctly, getting all of your derivatives. Let me rewrite that 6. But while I do that, any questions? If not, again, give me a thumbs up.
I have a quick question.
Oh, go for it, Dezante.
Okay, so I understand how the negative sign makes the -3 sine 3x positive, so we add that.
Mhm.
But the 3x plus 1, wouldn't that be negative, or what do we do to that?
So that 3x plus 1 is existing inside of a square, right?
Oh, okay, I see it now.
Yeah.
Thank you.
Yep, my pleasure. Any other questions? All right. Well, if you've got some, you're more than welcome to stick around. I know it's, well, oh, wow, 11:53. So you're good to go, especially if you got a 12 o'clock class. And good question, Samira. And the answer is no. Chain rule you'd have to be able to see that division as a composition of 2 functions. So when I'm looking at this derivative, the first thing I'm doing is I'm looking at the derivative of division. So that's why my Q is the first thing I do is quotient rule. And I apply quotient rule. If I wanted to do chain rule first, I'd have to be able to view this as the derivative of a function composition, which if you wanted to, you could find a way to do that, but it just wouldn't make your life a lot easier. If you want to stick around, I can show you how, but you'll see that it's just kind of convoluted. So in this case, because the division is what we see first, that's what we first have to deal with, I apply quotient rule, and then after the quotient rule is applied is when I see, oh, I'm taking the derivative of composition of functions in those individual pieces, and then that's when I apply chain.
Can you can you do an example?
Do an
Or
example
can you
of,
show me, I guess?
oh, the way, so we could view the derivative, so what did not the derivative, 3x, could we, I don't even know how to view this as a composition.
Because I thought we could use it and do the chain rule at the top and then the chain rule at the bottom, and then combine them to use the quotient rule.
So that's essentially what we did here though,
Okay.
right? Because you mentioned the quotient rule.
Yeah.
I just didn't calculate the derivative of the top and bottom beforehand,
Oh, okay.
which is probably what you did, and then plugged them into the quotient rule. So now that makes sense, the question that you're asking.
Okay.
So you're good, essentially.
So yeah.
If you see it now.
Okay. Okay, so we have to do the quotient rule first because I can see that that's a quotient. And
Mhm.
then after you did all that work on the top for the quotient rule, then you put the second and the third line, you use the chain rule for the second and the third line?
Just the second line. Because
Just
you
the
can
second
see
line.
from
Yeah, because the third line would be the answer. Yeah,
third line, all I did was just algebra.
yeah, that's the answer.
But
Yeah.
from the first line to the second line is where I applied my derivatives. And once I applied the derivatives, I dropped that d over dx notation because I'm no longer taking a derivative. And then all I did here was some algebra in that third line just to simplify
Okay.
what we have.
Now, see, I being that I didn't, I try to do what you said, not to go and look at my books for that whole day, and all of a sudden then I couldn't remember how to do anything on the homework. So I think I have to just stay in my books 24/7 so I can be remembering how to do this. I can't just leave the books alone. No. It
You can
didn't work.
definitely look at them. You can definitely look at them every day. That's not a bad thing. It's just when you're spending hours upon hours every day. That's when you're burning yourself out.
Yeah, and that's how come I couldn't get the rest of the homework problems finished, because then I said, oh my goodness, now I don't remember how to do it. Now, if I would have stood with the books for those hours on hours, then I would have been able to do my homework.
Well, you know yourself better than I do. So
Yeah.
definitely do what works best for you.
Yeah. Okay. Guess I have to go to my other class. Oh boy.
Any other
Okay.
questions from anyone?
Nope. Okay.
You're good, baby. I just want to make sure because we have a couple other people hanging around. All right, I don't hear anything, so I'm going to go ahead and end the meeting. I will see y'all Wednesday.